My name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will implement Autoencoder using TensorFlow, right? So in previous video, we had understand how Autoencoder works and how we can utilize it, right? So if you haven't seen that video, you can check it out in my playlist. Okay, so let's get started. So first of all, we will implement this using MNIST dataset. So we will refer this diagram which we had understand in a previous video, right? So I just imported a bunch of libraries here and we will start the implementing, right? So let's say first get the dataset, right? Okay. So for dataset we will use MNIST, right? So let's say mnist.load and it will return xtrain and ytrain, xstat and ytest, right? So let's say xtrain, ytrain, xtest and ytest, right? So autoencoder is unsupervised learning, so we will not require labels here, but just we are extracting, so we can use it if we require. For training purpose, we do not need any labels, right? Okay. Okay. So MNIST has no attribute load, right? Okay. So it is load data. Okay. Okay. So data set is downloaded. Let's see the shape, right? So it would be around 28 cross 28, right? Okay. Right. So now the 28 is our image size, right? So let's reshape it using 28 cross 28 cross 1, right? Basically only one channel image, so we can apply the convolutional operation, right? So let's say xtrain is equal to np.reshape xtrain, let's say -1, image size is 28, right? So let's put it into the new variable, right? Let's say image size is equal to xtrain.shape of 1, which is 28, right? And we will use this variable here, image size comma image size and 1, right? So this will become 6000 into 28 cross 28 cross 1, right? Same we will apply for the x test, right? X test will be, let me copy this line. Okay. So we need to pass x test here, right? Okay. So let's check shape. It would be 60,000 into 28 cross 1, right? Okay. So now this each pixel will contain value between 0 to 255, right? So let's normalize it to 0 and 1. So we can do xtrain is equal to xtrain divided by 255, right? And let's say xtest is equal to xtest divided by 255, right? So now our dataset is normalized and we extracted. Now let's implement this encoder part, right? Which will take an input as this 28 cross 28 cross 1 image and convert into latent space or bottleneck feature, right? So let's define encoder. Let's say encoder. Okay. So first we need to think, let's say how much we will use for the latent space, right? So let's say latent space or latent dimension. Okay. Let's say we will apply 64, right? Okay. And then let's how much filter we will use. Let's say filter size equal to, we will use first 32 and then 64. Just I am defining it. I will use, you can understand when I will implement it, right? So let's say encoder input will be input, shape would be image size, right? 20, which is 28 cross 28. Let's say image size comma 1, right? Let's give the name it to the encoder inputs, right? Okay, so now let's say x is equal to, we will use con 2D, right? Because we are using images, so we can deal with the images using convolutional 2D operation, right? So let's say filters is equal to, we will use filter size of 0, right? Now let's say kernel size we will use 3. Okay, now let's say padding is equal to same, and as you know, we need to compress our image, right? So we will use stride is equal to 2. So basically it will convert our image into half size, right? So let's say strides is equal to 2. Let's say activation will be our ReLU. Okay, and this will take input as an encoder input, right? Okay, so this is our first convolutional operation, right? So let's reuse this. Okay, so there is one issue. Okay, so we missed comma here, right? Okay, so we'll use same, but now filter size would be 64, right? So basically we will have 64 features, 64 dimension while we are applying convolution, right? Okay. Okay, so if you see, we start with 28 cross 28, right? Now we are just using stride 2 and padding same. Now our output will be 14 cross 14, right? And if you say this would be filter size 0, that means it would be 64 or 32, right? Now here if you see, we are using again stride 2, then it will half our image, so it will be 7 cross 7 cross, and filter size is 64, right? Okay, so we are extracting this shape basically, so we can use in a decoder. Just I am extracting here, I will explain when we can use this shape, right? So let's say shape before latent. Okay, so let's say x dot shape. Okay, now we converted into smaller dimension. Now let's flatten it and we will apply dense layer, right? So let's say first x is equal to, we will use flatten, and the input would be our x, right? Here it should be x, right? So now after flat, we will use dense layer, right? And dense, how much unit will be in the dense layer? It would be as our compressed representation, what we want, right? So we had defined we need 64 dimension, right? So here we are passing 64, right? And the x would be the input, and let's say this is encoder output, right? So this will be our encoder. Okay, so let's visualize this encoder so we can understand better, right? So we will use plot model method here, right? Plot model will be our encoder. Okay, so first we need to, I think, define the model. We are just use the functional API. Let's define the model. Encoder model will be model, and what would be the input and output of this model? Input would be this encoder input, right? Let's say encoder input, and output will be this encoder output variable, right? So now we have encoder model here. Now let's plot this. Okay, and let's say show shapes is equal to true. Okay, all right. So if you see here, we started with the 28 cross 28, and then the image will be resized into 14 cross 40, or we are extracting the feature and compressing the image, right? And then it will be 7 cross 7, and now we had flattened, so it become 3136, and then we converted the 3136 into 64 dimension, right? So this is encoder part. So we had implemented this much part, right? Now we need to implement decoder, right? So let's implement decoder. So if you see, decoder is almost inverse process of our encoder, right? So let's start first. Let me define here decoder. Okay, so let's say decoder input is equal to input, and here the input shape would be this 64, right? In this image we are using this latent space as an input of decoder. Okay, so let's apply this latent dimension as an input, right? Okay, let's give a name decoder input. Okay, now first we need to convert. Let me write and I will explain. So if you see, we have 64, right? So now first we need to convert it into this 3136, and then we will reshape that 3136 into 7 cross 7 cross 64, right? And then we will upscale it. Okay, so if you see, so dense unit we would require, let's say 1, 2 and 3, right? So basically we had extracted a shape from here, right? X dot shape, which is 7 cross 7 cross 64, and after flattening we receive this 3136, which is nothing but 7 cross 7 cross 64, right? So we had just get this 3136 from the 64. Now we need to reshape, right? We will reshape this using shape before latent. Okay, before latent of 1, two and 3, right? Okay, the shape will be in the tuple form, right? Okay, so what we had achieved here, so first we converted 64 into 3136, and now we had reshaped 3136 into 7 cross 7 cross 64, right? So here would be decoder input, and it will take x as an input, right? So now let's say x is equal to, we will use transpose convolutional operation, right? Con to the transpose. You can consider it as an upscaling the image, right? So now we had 7 cross 7 cross 64. Now we will convert it into 14 cross 14 cross 32, right? So let's say filter size. First we need to process the -1, right? This 64 part, right? Now let's say kernel size is equal to 3, stride is equal to 2, and activation activation is equal to relu, right? And padding would be same, right? And this will contain x as an input, right? So we need to process the same again. So now we will use filter size of -2, right? So we are doing reverse process. So first we had selected this 64, then 32. In encoder we started from 32 and then 64, right? So this all would be the same, right? Just filter size would be changed. So if you see here, we had achieved this till now, right? 28 cross 28 cross 32. If you see the output of it, it would be, let me write it here, okay? It would be 28 cross 28 cross 32, okay? And this would be 14 cross 14 cross 64, right? Okay, so now we need to convert this 32 into 1, right? Because we need to predict one image at a time, right? So let's use same line, but we will change the filter size equal to 1, right? So now our filters will be 1, and we will not use stride here because we don't want to change the output, right? So we will not use stride here, and padding would be same. So we will get the output 28 cross 28, but as filter is equal to 1, that's why we will receive 1 here, right? Instead of 32, which is our input dimension, right? Okay. And now here activation, we will use sigmoid. Why we are using sigmoid? Because if you see here in the input, we had normalized our xtrain and xtest, right? So this xtrain and xtest contains the value between 0 and 1, right? And sigmoid will provide value between 0 and 1, right? Okay. So it will be decoder output, right? Okay. No keyword argument, strides, okay? Okay, so it would be strides, right? Okay, so let's build decoder model. Will be model, and what will be the input? Input will be decoder input, and output will be decoder output, right? So this is our decoder model. Let's plot this model as well and see the shape of each layer, right? So plot model, and let's say decoder model, and show shapes is equal to true, right? Okay, so you can see here we started from 64 dimension, right? Then converted into 3136, then 7 cross 7 cross 64, then 14 cross 14, and then 28 cross 28 cross 32. And at last, this line will change this filter size, basically a feature map, which is into 32 to 1, right? So now at the last we have received our image 28 cross 28 cross 1, right? Now let's write the code for autoencoder, right? So we had built two major part of the autoencoder, which is encoder and decoder, right? So now we need to use both of them, okay? So let's say autoencoder is equal to model, and input will be encoder inputs, right? And what will be the output? Output will be, let's say, decoder model with encoder model of encoder input, right? So input will be the encoder input, but what will be the output? Output will be, we first calculate the output of encoder model, which is the bottleneck features, and we will pass that feature into decoder model, right? So this is our autoencoder model. So let's plot this as well. Plot model, autoencoder, and show shapes is equal to true. Okay, so this is the same as this diagram, right, which we have seen above. So first is the encoder, and then we are converting into 64, and that 64 will be passed to the decoder, and we will get 28 cross 28 cross 1, right? So let's train that model. Okay, so let's write training here. Right, so let's first compile our model. Autoencoder dot compile, and let's say loss, we will use MSE, which is mean squared error, and let's say optimizer is equal to Adam. Okay, so let's compile our model. Okay, so model is compiled. Now let's define some variables. Let's say batch size is equal to 32, and let's say epochs is equal to 2. We will initially train for the 2 epochs and check the output. Okay, so let's say now fit it model, right? Autoencoder dot fit xtrain. Our output will be also xtrain, right? Because we are trying to predict the same as an input, right? Okay, let's say validation data will be xtest and xtest, right? Okay, and let's say epochs is equal to epochs, which is 2, and batch size is equal to batch size, which is 32, right? Okay, so let's run this and model will train, right? Okay, so you can see the loss is pretty low, which is good, right? So let it train, and let's define one method which can predict for a single image, right? So let's say define predict single, and it will take x, which will be our 28 cross 28 cross 1 image, right? So we need to first expand this, np dot expand dims. Let's say x is equal to 0. So basically what we are doing here, so our input will be 28 cross 1, and we are converting into 1 cross 28 and 1, right? So basically we are adding one extra dimension here, which will treat it as a batch size, right? So let's say result is equal to autoencoder dot predict, right? Autoencoder dot predict x, and as we had extra added one dimension, we will remove that, right? So let's say return np dot squeeze result, and axis will be 0, right? What we are currently doing, 1 comma 28 comma 1 into 28 comma 28 comma 1, right? Okay, so this is predict single. Let's predict for one image. Pred is equal to predict single, and we are passing, let's say, x test of 0 element, first element of test set, right? Okay, so this is prediction. Let's plot this as an image. I will use a matplotlib plt.im show. Let's say pred and cmap is equal to gray, so it will print in a grayish image, black and white image, right? So this is our prediction, which is 7. Let's see what was the actual test set, right? So we had pass x test of 0, right? Okay, so it is also 7. You can see it is very similar to what we had passed as an input, right? So we can say the autoencoder is trained properly. Okay, so now this is all pipeline, right? So if we want to just extract the embeddings, so we can use our encoder, right? Let's say encoder output. Okay, so it will be like, say, encoder prediction is equal to encoder model dot predict, let's say x test. First 2 we will pass, so we don't need to provide extra dimension, right? So we will predict at a time 2 here, right? So if you see the shape of it, will be 2 cross 64, right? Yeah, so we had predicted 64 dimension vector for these 2 images, right? And this 64 dimension vector you can use as a feature for this MNIST data set, or you can use it in a dimensionality reduction vector, right? So this is all about the encoder or autoencoder, right? So if you have any doubt, you can ask in the comment section, And if you like my video, please press the like button and subscribe my channel. We will meet in the next video. Thank you.